Okay, simplifying algebraic expressions, chapter 7, lesson 2. This is pretty much combining like terms. Parts of algebraic expressions. So this is very important because when I'm in class and instructing this material, I will be using these key terms. So 3x, 7x, and 2. Those are all terms, okay? The term 3x is made up of a letter and a number. The number in this case is known as the coefficient. The x is known as the variable. The 7, okay, is a term, but the 7 has no variable with it whatsoever, so we call that a constant. The x is just all by itself, although we need to remember that there is a 1 in front of it. So 1 would be the coefficient and x would be the variable. The number 2, since it doesn't have a variable with it, we call that a constant. Okay? So constant is referred to the bottom of the model down there with the like terms and the constant. Okay? So let's just go ahead and get practicing. You guys can refer to example 1, both A and B, on your own, but I'm going to go ahead and get started with the got it question. Number 1, identify the like terms. So I'm going to try and use colors here to help you identify like terms. So you have the terms with the x values and you have the terms with the y values. Okay, now you also have to be careful of the signs in front of the terms, not behind it. So the negative 4x, okay, is one term that can be combined with the positive 2x, okay? And then you have the positive 2y that can be combined with the plus 3y. So those are your like terms. That's all you had to do for this problem. Once you get to example 2 on page 300, please read over the example on your own. I'm going to go straight to the got it question. Identify the terms, the like terms, the coefficients, and constants in the expression. Okay? So we've got 1, 2, 3, 4 terms. Okay? So we've got 4 terms. One of them is a constant. So constant term, that's 2. Then we have the 3n term. Okay, that has a coefficient of 3 and variable of n. Then we have the 5m term. So we've got the coefficient of 5, variable m. And then, of course, the last term, we've got negative 6m. That's that term. So the coefficient of that one is negative 6. And the variable is m. So then in this expression, you would only be able to combine those 2 terms together because all the other ones are different. Okay? So in example 3, this is where you actually start combining the like terms. Please go through and read all the examples on your own. But I'm going to get started with the got it questions at the bottom on page 300. So we've got 4x plus 6 minus 3x. So notice that we have two terms, okay, with an x in it, and the only term that was left is a constant because it doesn't have a variable. So we're going to go ahead and combine the 4x and the negative 3x. Okay, I'm going to go ahead and write that out separately so I can easily see what operation to perform with them. If I have 4 values of x minus 3 values of x, I am left with 1 value of x. And then I'm going to rewrite that expression with the only constant left. And this is my simplified version. Now note, I do not have to write in 1x. I can put in x plus 6, and that would be my answer as well. Go ahead and try 3b and 3c on your own. Pause the video, press play when you're ready. Okay, go ahead and check your answers for 3b and 3c. 3c was kind of tricky because you had to do the distributive property with the factor of 4. So please note that 4 gets multiplied to the q, and since it's multiplication, okay, you can actually go ahead and multiply 4 times 8p because you have to think. This is basically multiplication is a shortcut to repeat addition. So if I added 8p's 4 times, okay, we can do that. It's just a shortcut to multiplication. So you're able to multiply 4 times 8p and get 32p, okay? And don't forget, the biggest mistake that I've seen within my years of teaching has been this right here, okay? People are forgetting about that extra p on the end in order to combine it with the 32b at the end, all right? So you end up getting simplified version, 4q plus 33p. Okay, on page 301, read through example 4 of the financial literacy, and then pause the video, read through it, and push play. Okay, when it comes to writing expressions, it's probably the hardest thing in mathematics, even when dealing with geometry, okay? If you don't have any issues or if you're not struggling with writing expressions, good for you, okay? But usually writing expressions is the most difficult to understand in order to get our brains wrapped around this subject. The easiest thing I can say to you is to memorize each situation and how to write an expression. If you do not understand how to write an expression, then you have to memorize, okay, on each scenario. You have to memorize each scenario that we form an expression for, okay? And then hopefully from there, you will get stronger with that ability. Otherwise, if you can make sense of it, okay, then that's great. Otherwise, I am perfectly okay with you not getting it, but having to memorize it, okay? So, if you look at this problem, we're just going to go ahead and go through the got it questions. Motto and Lola both collect the stamps. Okay, Lola has, okay, so when she has it, that means that's what she equals. Lola has 16 more stamps in her collection than Motto. So if I take Motto's number of stamps and add 16 to it, I will have Lola's collection. Now, Motto, we don't know what he has. Okay, so he's just going to be simply just M. All right. Now, write an expression in simplest form that represents the total number of stamps in both collections. Now, realistically, we would want to write, well, if I just take Motto plus Lola, I will get the number of stamps. But when it comes to this example, from up top, they have 2 variables, okay? So we're going to replace the L with what L equals. Okay, and that's this right here. So your new equation will look like this. M plus 16. Now it's okay that I rearranged the 16 and the M. Okay, we're allowed to do that for the commutative property, if you remember. So I'm going to go ahead and simplify this. If I have one M plus another M, I'm going to get 2M. And then the constant 16 can't be combined with anything else. So this is our expression for 4A. Now look at 4B. Derek has as many stamps as Motto. Write an expression to represent the total of all 3 collections. So when Derek has as many stamps as Motto, that means Derek pretty much has the same as Motto, so he can equal Motto. This name Motto sounds ridiculous. Anyway, so if I have Derek equal M, Motto equals himself, and Lola equals 16 plus M, well, then I can add Motto plus Derek and plus Lola. So, okay, Derek plus Motto plus Lola what we have to do to figure out the combined amount, right? So just replace the D, or just replace each expression, I guess, with the letter. So we're going to replace D with M because Derek equals Motto. M just stays M. And then you already have the experience with L. L is just M plus 16. So now we have 3 M's plus 16. And that's a simplified version for 4B. If you don't get this, it's okay. Okay, we'll try to get more practice with this as we go along. To get some guided practice or some guided help, go ahead and do 1 through 14 on a separate sheet of paper. When you're done, okay, the answers will be on this video. So if you have any questions, let me know. Otherwise, pause the video, do all the problems, and then push play for your answers. Okay, here's problems 1 through 6. Note that you had to list the terms, like terms, coefficients, and constants for each one. Pause your screen, correct any mistakes you might have. Okay, moving on to the next screen. Here's problems 7 through 12 that you actually had to combine like terms. Notice that wherever I changed it to a plus negative, okay, I just did the additive inverse, and then I just rearranged my numbers, my terms, to where I can combine them more easily. So in number 9, you can see where I changed it to plus negative 5x. Well, then I did the commutative property and then just combined like terms that way, okay? So go ahead and pause your screen, get the rest of your answers, and then move on. Okay, for 13 and 14, if you memorize the technique that we did in our notes, okay, it's pretty much the same technique. However, number 14, they give you the price for DVDs in the book. So those are going to be your constants, okay? The 3x is the value that we didn't know for the CDs, so that was our only variable. When you combine all the like terms together, you get 3x plus 35. If you have any questions on this, please come and see me, all right? Because we need to get this taken care of if you don't understand it. Finally, go ahead and get started with your independent practice, page 302. Numbers 21 through 43, you're only going to do the odd numbers, okay? I don't expect you to do all of that. And then please do problems 46 and 47.